Hi everyone, today we are going to be learning about identifying substances and combining substances. Okay, so you're going to work through this video lesson and you're going to learn about those two things. We're going to talk in depth about a few things, okay? So, the properties of matter is what we're going to start out with. So, when you encounter an unknown substance, you can use its properties to help you identify it. So, an example, when a large piece of glass breaks, its appearance changes, okay? So instead of one solid sheet of glass, it has holes and cracks, sort of like this picture off to the left side. It's still the same color and hardness, but it has changed in other ways, okay? So think of a window, okay? If you throw a rock at a window, you might break it, you might crack it, right? So it's still glass even though it's broken, but it's changed. The way that it looks has changed, its appearance, okay? Some properties of matter will always be the same whether you have a small amount or a large amount of it. Here are some examples. So, property color, aluminum metal is gray colored, right? No matter how much I have of it, it's going to be gray. Taste, lemon juice tastes sour. Magnetism, iron is attracted to magnets. Boiling point, the boiling point of water is 100 degrees Celsius, 212 degrees Fahrenheit. Hardness, diamond is the hardest known substance, okay? So combining substances. And I love the example they give here because it makes a whole lot of sense. So, matter can exist as a solid, liquid, or gas and can change in different ways. In some changes, the substances are essentially the same and retain their properties. So I know that's a lot to take in, but it's all going to make sense when we look at our example here. So if you cut a carrot and a stalk of celery into 3 pieces each and mix them together, you still have the same substances of carrots and celery, right? So if I take a piece of carrot and I chop it up into small pieces, and I take a piece of celery and I chop that up into small pieces, and then I put them all together in a bowl and I mix them up, do I still have carrots and celery? Yeah, I do, right? Okay, the celery is still green and it tastes like celery. The carrot is still orange and it tastes like carrot. Okay, so the 3 pieces of carrot and the 3 pieces of celery will weigh the same as the original carrot and celery stalk. Both will weigh the same even though they've been cut up, right? So it doesn't matter. Even if I take a piece of carrot, I cut it up. Well, let's say I take a carrot, I weigh it. Then I take it and I cut it up and I put those pieces on the scale again. It's gonna weigh the same. It's gonna taste the same. It's gonna just be cut up into pieces, so it'll look a little bit different, right? Its appearance changed. Melting is a very important part, and we're going to talk about this. So, melting is an example of a special type of change, which is a change of state. So, they always use this example, and I think it's a good one. The shape of an ice cube changes as it melts and becomes a liquid. So, think about going to your freezer and getting a piece of ice, okay? That piece of ice is going to change over time, right? If you leave it sitting out, it's going to change as it melts. However, the matter does not change, right? It still has the same taste, and your body will be able to use it in the same way. So if you eat a piece of ice, okay, that's water that's going into your body. If you melt a piece of ice and then you drink the water, that's water that's going into your body. It's still water, so it's a change of state. Other changes of state include evaporation, which is a liquid to a gas, freezing, which is a liquid to a solid, so if you freeze water like in an ice cube tray, and condensation, which is a gas to a liquid. Combining substances, this is kind of continued on from the carrot and celery example, but when 2 or more substances are combined, sometimes they produce a new substance with different properties. And I know that text is tiny. I don't know why it's so tiny because it wasn't tiny when I made the PowerPoint. Anyway, so an example is baking a cake. Okay, and I love this example because I think it's a great one, okay? So when you begin with the ingredients for the cake, you have flour, sugar, eggs, liquid, and flavoring, which all have unique properties, right? You can observe an egg. Like if I showed you a picture of an egg, you could tell me that's an egg, right? And you could describe it too. Let's see. You notice the cake is done when it's a particular color, is tall and fluffy, and separates slightly from the edges of the pan. The properties from the finished cake are different than the original ingredients. So I take all those ingredients in a cake and I mix them up and I create a cake, right? So I take flour, sugar, eggs, maybe vanilla extract, which gives it flavoring, maybe cocoa powder, right, which would make it chocolatey. Okay, and I combine all those things together. When I bake my cake at a certain temperature, let's say I put it in the oven at 350 degrees for 20 minutes, right? When I bake that cake and I pull it back out, it's different, right? All those ingredients have mixed together, they've baked together, and they've created something new, okay? That's a great example. I love it. Okay, so this is an example of products that are mixed together and create a new substance, okay? Thanks for watching. Go ahead and complete the activity, the assigned learning activity, by clicking on the